Myself, Jagadeeswari, KSR College of Arts and Science for Women, Tiruchengood, Department of ADS, Fundamentals of Data Science. First topic is normal distributions and their scores. Normal distributions are bell-shaped sigmometric probability distributions that model many natural phenomena. Key characteristics means median, mean and mode are equal. Symmetric, about than mean. Approximately 68% of data falls within first standard deviation. Second one, approximately 95% of data falls within second. Third one is approximately 99.7% of data falls. Z-scores tell us how many standard deviation are a data points is from the mean. Next topic is finding properties using the normal curve. The normal curve allows you to find the proportions of values that fall within specific ranges. K. Z-scores landmarks. Z is equal to 0, the mean, fifth percentile. Z is equal to plus or minus 1. Z is equal to plus or 2. Z is equal to plus or 3. Approximately 68% and then 95. Last one is 99.7% of data falls. Finding properties. Convert raw scores to Z-scores using Z is equal to x minus mu. Use of a standard normal table or calculator to find the area under curve for ranges. Find the difference between two Z-scores areas. For example, if exam scores are normally distributed within 75 and then 8, what percentage of students scored above 83%? Z is equal to 83 minus 75. 8 is equal to 1.0. And then area above Z is equal to 1.0 is equal to 1587 or approximately 15.87%. And the next topic is finding scores and applications of Z-scores. Finding scores from percentages. Determine the Z-score corresponding to that desired percentile. Use the formula x is equal to mu plus z. X, for example, find the score that represents the 90th percentile in a normal distribution with mu is equal to 5. The Z-score for the 90th percentile. Additional applications of Z-scores. Comparing scores from different distributions, setting cutoff points for selections process, identifying outliers, creating confidence intervals, hypothesis testing. And the next one is correlation and scatter plots. Correlations measures the strength and directions of linear relationships between two quantitative variables. For example, ranges from -1 to +1. R is equal to +1. Perfect positive correlations. R is equal to -1 is negative. +1 is positive and then -1 is negative. R is equal to 0. No linear correlation. Formula R is equal to sum. Important considerations. Correlations does not imply causation. Outliers can strongly influence correlations. Correlations only measures linear relationships. Always examine scatter plot visually alongside a or values. Next one is compute formula for correlations coefficients. The computational formula for the correlations coefficients is R is equal to n sum xy minus sum x sum y divided by square of sum is equal to minutes. Calculations. Create a table within columns for x comma y comma xy comma x squared and y is squared. Find the sums sum x sum y sum xy and then sum x squared sum y squared. Substitute values into the formula. Formula data points. Example calculations for data points 2, 4, 3, 5, 5, 7, 7, 10 and then 9, 12. Table with the sums. Sum x is equal to 26, sum y is equal to 38, sum xy is equal to 236. Sum x squared 168. Squared is equal to 334. Introduction to metabolic matplotlib is a comprehensive visualizations library in Python that enable the creations of high quality publications ready graphics. It serves as the foundation for data visualizations in the Python features. Object oriented API for control over visualizations elements with arrays and data frames. Extensive customizations options for colors, styles and formattings. Support for multiple output formats, PNG, PDF, SVC, integrative displays and then basic structures. Image of metabolite plot shown. Line and scatter plots visualing and relationships. Line plots ideal for showing trends over continuous variables time series functions and then real patterns, trends and relationships between variables. Can display multiple series for comparison. Customization options and then next point is line styles solid dashboard data. Last one is line without and transparency. Scatter plots means perfect for displaying correlations between two variables. Each point represents an individual data point, can encode additionals and within. And then next one, density visualization and histograms. Density and control plots visualize 2D distributions and probability densities. And then heat maps display data as color coded matrix. Creating contour plots Python code example. Histograms and density estimations. Histograms groups data into bins to show frequency distributions. And then kernel density estimations KDE. Smooth representations of data distributions, less sensitive to binding choices than histograms. Implemented with skip states. Example histograms comparison Python code. 3D visualizations and geographic data. 3D plotting. Use common 3D plot types. First one is line plots, AX plot 3D XYZ. Scatter plots, AX scatter 3D XYZ. Surface plots, AX plot surface XYZ. Wireframes, AX plots wireframe XYZ. 3D visualizations best practice. Include clear axis labels within units. Use approximate viewing angles AX view unit. Consider animations to show multiple perspectives. Use color to represent it and then additional dimension. Geographic data visualizations. Advanced techniques and best practice. Subplots and then multi-panel figures. Next point is integrative visualizations. Interactive visualizations and then hover tools within plotted integrations. Saving animations with metabolic animations. Best practices for data visualizations. Choose approximate and then plot types for your data. Thank you.